Alright, today's lesson is 13-6, sigma notation. Today's date is today. Our objective is to represent a series using sigma notation. Well, I'm sure you guys are asking yourself right now, what does sigma mean? Or sigma notation mean? Well, sigma is the Greek letter, and this is actually a capital sigma, and it's often used to express a series or its sum. So, for example, this one would be read as the sum of k squared from 1 to 100. So all I'm really doing is taking that k squared and plugging 1, 2, 3, 4, 5, 6 continually until I reach 100, and then you could add those together. So on this first one, what that really means is I'm taking 3 times k from 5 to 10. So that'll be 3 times 5 plus 3 times 6 plus 3 times 7 plus 3 times 8 plus 3 times 9 plus 3 times 10. So 15 plus 18 plus 21 plus 24 plus 27 plus 30. That's what that represents. On the one here, I've got the sum of negative 1/2 to the nth from 1 to 4. So that just really means negative 1/2 to the first power plus negative 1/2 to the second power plus negative 1/2 to the third plus negative 1/2 to the fourth. I don't want to leave it like that. I can simplify this a little. I'm going to get negative 1/2 plus 1/4 minus 1/8 plus 1/16. And then if I wanted to, I could go ahead and add those 4 up. Some properties of finite sums. If on that first one I've got a sub I plus b sub I, what that means is you can separate each of those and do the summation of each of them and then add them together. The bottom one, I've got c times a sub I. C is a constant. I can move a constant out in front and work it out that way. So write the series in expanded form. That would just be 2 plus 3 plus 4 plus 5 plus 6, because I'm going from 2 to 6. I'm not sure why in the notes I put the same example down twice. I'm going to skip this one. And let's do this one. 3k minus 1 from 2 to 6. 3 times 2 minus 1. And a lot of these I think you could probably do in your head. I'm just going to write everything down right now. 3 times 3 minus 1 plus 3 times 4 minus 1 plus 3 times 5 minus 1 plus 3 times 6 minus 1. And again, we want to go ahead and simplify those out a little. That would be 6 minus 1. Oops, didn't mean to put a comma there. I definitely meant to put a plus sign. 9 minus 1, 12 minus 1, 15 minus 1. Gosh darn it, I did it again. And 18 minus 1. If you notice, this is an arithmetic series. it's going up by 3 each time. That's what that 3K is telling you, that it's going up by 3 each time. So let's go ahead and figure out some of these right here. Well, it looks like this is going up by 4 each time. So I'm going to start by writing a sigma sign. And it's going from 1, and it looks like I've got 5 terms here. And now I need to do the hard part. I need to figure out what's going on. A lot of times people notice that it's going up by 4, and then there's a tendency to write n plus 4, but that won't work because 1 plus 4, 2 plus 4, 3 plus 4, 4 plus 4, they don't match up with any of these numbers. If I thought of this as 4 times 1, 4 times 2, 4 times 3, it's still going up by 4 each time, but what I'm really doing is I'm multiplying the term, the sequence of that term, by 4. So that is going to be 4n. The trick on that is realizing when you do go up by a certain number each time, in this case 4, chances are you're going to have a 4n, a 4k, 4x, whatever variable you choose to use. Let's do another one. Well, on this, it looks like it's going up by 2 each time. And it's going all the way up to 200. So if I just take 200, divide it by 2, I get 100. So I know n is 100. So let's go ahead and do our sigma. Again, it's up to you which variable you choose. N is going to be my choice here. Sometimes you might see k, you might see I, and it's going from the first term to the 100th term. And again, since it's going up by 2, there's that tendency to want to put n plus 2. That won't work out if you test it. That's right here is 1 times 2, 2 times 2, 3 times 2, 4 times 2. So that is just going to be 2n. All right, enjoy your sigma notation.